share. Can y'all see my Word document?
Yes, ma'am.
Okay. All right, let's get started. Okay. So we are on page 114. We're going to do the last example on page 114, part C. And so part C is that Z1, which is the first complex number, is equal to the square root of 2 minus the square root of 2i. And then Z2, which is the second imaginary number, is 1 minus I. And what they want us to do is they want us to multiply these two things together, and they want us to divide these two imaginary numbers. Now, if you were to multiply, okay, I'm going to show you something. I don't want you to do this, okay? I'm just going to show this to you. Just watch. Be entertained by the show. If we were to do this, we would have the square root of 2 minus the square root of 2i, and we would multiply this by 1 minus I. So we actually did this back in the beginning of the section where we FOIL this bad boy out. If we FOIL this out, we would get, don't want to lie to you, square root of 2 minus the square root of 2i, right? Inner would be negative square root of 2i. I can't write today. You're going to have to help me a lot because I say it, but I don't write it. So it would be negative square root of 2i. And then last would be plus the square root of 2i squared. Do we agree with that? Yeah. And that would give me the square root of 2 minus 2 the square root of 2i's minus the square root of 2. The square root of 2's would cancel, and you would just have negative 2 the square root of 2i. Does everybody agree? I'm going to look over my work. I FOILed it, so it'll be the square root of 2, negative square root of 2i, negative square root of 2i, yep. And then positive square root of 2i, so yep. I squared, remember I squared is negative 1. So that's how I got that negative square root of 2. Those canceled. Is everybody okay with this? Any questions? Okay, so this is how you could just multiply them. I multiplied them, and here's the answer. Does that make sense? To divide them would be harder because you would have to take Z1 divided by Z2, multiply by the conjugate on top and bottom, and simplify. But you could do it. It's not bad. It's a little bit more complicated. What we're trying to say is that if you were to switch these to polar, doing these operations is a lot easier, okay, because you have these formulas. So let's change these to polar. So the first we're going to change Z1 to polar. So let's do that first, okay? So hopefully we remember this from yesterday, that if you change Z1 to polar, first we have to find R, which is the absolute value of Z1, which gives you the square root of 2 plus 2, right? Wouldn't that just equal 2? And theta would equal tangent inverse of negative square root of 2 over square root of 2, which equals tangent inverse of negative 1. Are we okay? I had a lot of coffee today, so I'm just like excited. So just let me know. Are we okay? I'm going to yell for my daughter. Let me look over that, make sure we're okay. Testing, testing. Oh, sorry. Okay. I guess we're okay. Nobody's talking. So what's theta? Anybody come up with theta? I'm doing a sound check. Put a thumbs up in the chat if you can hear me. Let me know.
No, I can't hear you. I got in a little bit late, so I'm trying to catch up.
Okay, cool. I just want to make sure because I'm like talking to myself.
No, I was doing my thing, trying to write as fast as I could so I could start answering your questions.
Okay, this is a show. You don't have to write that. I'm just going to show you something with that. It's more this. You don't have to do the show like on your homework. You don't have to do it twice. I'm just trying to show you that it's the same thing and
Gotcha.
why it's easier to do it in polar once you get it into polar form. So theta is, what is theta? 7 pi over 4? Are we okay with that? If we're trying to stay with a positive angle? So that means that Z1 would equal 2 open parentheses cosine of 7 pi over 4 plus I sine of 7 pi over 4. So we haven't really done anything yet. All we've done is change Z1 from complex form to polar form. That's all we've done. And we only did one. We have to do Z2 as well. Any questions? All right, let's do Z2. Ready for Z2? So now what we're going to do is we're going to change Z2 to polar. If I do that, your R equals the absolute value of Z2, which would be the square root of 1 plus 1, which is the square root of 2. And theta would equal tangent inverse of negative 1 over 1, which is still so we get 7 pi over 4 again, don't we?
Yep.
So then Z2 is equal to the square root of 2, open parentheses, cosine of 7. Yes, ma'am. Sure would. Thank you for the catch. Plus I sine Are we okay? Are there any questions on how to change complex to polar?
I'm good here.
Jefferson's good. Cool. Thumbs up there. Anybody else?
Yeah, I'm good.
Garrett, thumbs up. Sound good? Any questions or anything came from? Everybody understand why it's 7 pi over 4? Okay. Now we are ready, since they're both in polar form, we are ready to answer the question. So the first one says, I want you to find Z1 times Z2. If you do that and you go back to the formula that we learned yesterday, you're going to multiply your R's together. Do you agree that if we multiply our R's together, we would get 2 the square root of 2? Right? Because our R for Z1 was 2, and our R for Z2 was the square root of 2. So 2 times the square root of 2 is 2 times the square root of 2. We okay with that? Does anybody remember what we're supposed to do with the angles from yesterday?
Add them together.
You do. You add them together. So then do you
But
agree
wouldn't
that
it just be the same thing since it's all the same? If you added them and then simplified, it would just come out to this.
I don't know, you tell me. What's 7 pi over 4 plus 7 pi over 4?
Yeah, the same thing. Same thing.
14 pi over 4? Do we agree with that?
Oh, yeah. So it'd be 7 pi over 2 now.
How many times is 4 going to 14? Simplify 14 pi over 4 is what I'm saying.
It's 7 pi halves.
Yeah.
Okay, so then I agree. I'm with you. The thing is, though, if I wanted it to be within the unit circle, the first rotation of the unit circle, I should say, what could we change that to? So remember,
Upwards?
this right here would be, if you put 14 pi over 4 in, you would get 7. You said that this reduces down to 7 pi over 2. 2 goes into 7, 2, 4, 6, 3 times. Do you agree with that?
Yes, ma'am.
then
Then you have a pi half left over.
A pi half left over. So I want you to think about where that happened. So on the unit circle, 1, 2, 3 pi. Wouldn't we end here? Is everybody okay with that?
Mm-hmm.
So couldn't I write this way? Isn't that a coterminal angle? We would end up in the same spot, but I'm only going one rotation. I'm within one rotation of the unit circle. I'm stopping. So we did Z1 times Z2. We multiplied the R's. I think everybody's okay with that. We added the angles. So 7 pi over 4 plus 7 pi over 4 gives you 14 pi over 4. However, you went more than one rotation around the unit circle. So if you simplify that, that's 17 pi over 2, which of course is 3 1/2 pi. So if you come over here, I'm going to do it in a different color, and you start where you're supposed to start. Here's 1 pi, 2 pi, 3 pi, and a half. Isn't that 3 pi over 2 on the unit circle if you're only allowed to do one rotation? So you would end up in the same spot. Does that make sense?
Yes, ma'am.
Okay. Now,
Makes sense to me.
something I want to show. I'm showing this. You do not have to write this. I'm showing it. So if you're still writing the black stuff, like the part that's the answer, let's say that I wanted to simplify this. So I would have 2 the square root of 2. What is cosine of 3 pi over 2? Isn't that 0? Plus, what is sine of 3 pi over 2? Isn't that negative 1i? Because sine of 3 pi over 2 is negative 1i. And so then inside the bracket, you would just have negative 1i. And negative 1i times 2 the square root of 2 is negative 2 the square root of 2i. Notice what we have here and what I showed you earlier. It's exactly the same thing. Now, some of y'all, while you're looking at this, might be saying, but I would rather do it this way. I would rather do it this way because that was so much easier. I FOIL and I get the answer. And I got the same answer you did, except this is in polar form. Why can't we do it this way? Because if I were to do something like this, 4 plus 6i, and I want you to raise it to the 15th power, this is not the easy way. You don't want to write this out 15 times and then FOIL it. It's way easier to do it the polar way, which I'm going to show you today. That makes sense? So we're practicing doing this in polar form so that when we start to get stuff like this, 4 plus 6i to the 15th power, you're like, oh, I'm just going to do it in polar form because it'll be easier. Okay? So that's why we're practicing. Go ahead.
You also couldn't graph it that way in the show, could you? Because it has to be in polar form.
Well, it's easier to graph in polar form. Which but I wouldn't even know how to put these in because they're just points. There's 1 point. So that's a good question too. I don't really know how to graph it unless it's like r comma theta form, r equals something.
Gotcha. Okay.
Yeah,
that makes sense.
Mm-hmm. Like on your like even on a rectangular plane, if you go to y equals on a rectangular plane, I say I just want you to plot the point 27. That's hard to do, just to plot the point 27 on your calculator. You actually have to have a full equation. So these are just points. Okay? Okay, so now we're going to divide. So it's back to you writing. I want to do Z1 divided by Z2, which is actually pretty hard to do in complex form. So Z1 divided by Z2, you divide the R values. So if you divide the R values, you get the square root of 2. And then what do you do with the angles? Does anybody remember? When you divide, what do you do with the angles?
You subtract.
Mm-hmm. Yeah, you do. You subtract. And what is 7 pi over 4 minus 7 pi over 4? Thanks, Jude.
0.
Yeah. And so here's your answer. That's it. That would be your answer of division in polar form. And then, of course, if they wanted you to tell me what the answer was in complex form, you would just do what we did in the show. We would simplify this and distribute the square root of 2. Please ask, is there any questions on the division part?
How'd you get this? Am I just having a little brain moment? How'd you get square root of 2 for?
Oh, sure.
2
so
over.
If you look over here, yeah. If you look over here for Z1, isn't Z1 2? The R value is 2 divided by the square root of 2. That's improper. So I'm going to multiply.
Oh yeah, you just rationalized it.
2 the square root of 2 over 2. The 2's cancel.
Duh.
Anybody else? No, it's okay. I've had like 3 cups of coffee.
You're feeling it today.
I am so feeling it. Anybody else?
We're vibing right now.
Okay, so this is how you multiply and divide complex numbers in polar form. Okay, so now we're going to get to De Moivre's theorem, which is raising, like I showed you earlier. Did I erase it? Like if I wanted to do 3 plus 5i to the 5th power, how would I do that? Okay, so what we're going to do, I'm going to get a fresh page. Let's start fresh. So De Moivre's theorem says, let's say that you have a complex number. It's R. You do not have to write this down. I'm literally writing down what you have on the bottom of page 114. Cosine theta plus I sine theta. Okay. And let's say you want to take this complex number and you want to raise it to the nth power. Well, then all you have to do is take your R value and raise it to the nth power. And then you're going to multiply your angle by n. And that's it. That's all you do. And of course, you can change it to complex if you need to, but that would be the answer. We okay? So I'll do the first example with you. We're going to do the first example together. So if you look at example 1, it says 1 minus I to the 10th power. Now, could you, if you wanted to, write 1 minus I out 10 times and then FOIL it all out until you got one answer? Absolutely. Hope you don't make a mistake. Make sense? And remember, you only have a 2-hour test. So doing it that way is not effective. It's really long and not effective. So when you get to this point, you're like, oh, but I have to do it. So let me go ahead and change it to polar form. It is easier to work in polar form than it is to complex. So the first thing that you have to do is you're going to have to change 1 minus I to polar. Right? So I'm going to come over here and find R. And you have to find R by finding the absolute value of your number. So that would be the square root of 1 plus 1, which equals the square root of 2. Is that okay? Then you're going to find theta. And you know that theta is tangent inverse of negative 1 over 1. We agree? Hey, that is 7 pi over 4 then? I don't know why I'm working 7 pi over 4 today. Okay, so then we have that our imaginary number in polar form is the square root of 2, open parentheses, cosine of 7 pi over 4 plus I sine. We okay with that? Any questions?
Not yet.
All right. So then the next part is it wants me, so here's the second part. Now that we have that in polar form, it wants me to take z and raise it to the 10th power. So that means, you would have the square root of 2 to the 10th power. You raise r to the same power. And then it would be cosine of 10 times 7 pi over 4 plus I sine of 10 times 7 pi over 4. Ooh, help me. That'd be what, 5 times? 32?
That's what I got.
Okay, cool. Oh, let's just do it, because I don't know. I'm trying to do it in my head and I can't. What is this, 70 pi over 4? I'm going to stop there for just a second and talk to y'all about this. Everybody okay with where this came from? Everybody good? Okay. While you're writing this down, on your homework, if it doesn't say anything in the instructions about fixing your angle, then your angle probably doesn't need, like, they don't want you to fix it. Well, I mean, you can. I would count it right either way. But this is you just sitting around going around the circle a million times. Does that make sense? And it would be hard for me to simplify like this because I have no idea what 70 pi over 4 is. Like if you were to ask me, don't know. Does that make sense? So I would change it. What does 70 pi over 4, what does that equal? How many times is 4 going to 70?
I got 17 with 2 pi fourths left over.
So 17 with a half left over? Pi?
That's what I got.
Okay, that's cool. So then where is that in one rotation? You know what I'm saying? So you have 2, 4, 6, 8, 10, 12, 14, 16, 17 and a half. So wouldn't you end up here?
Yes.
Does that make sense what I'm saying to everybody? So this and this are the same thing. You're going to get the same answer. Even if you simplify it, you get the same answer. But if they tell you in the instructions that your angle has to be between 0 and 2 pi, this is what I mean that you have to fix it. Because 70 pi over 4 is not in between 0 and 2 pi. So you have to come over here, change it to a mixed number, right? And then figure out where you are on the unit circle within 0 and 2 pi. And it would be the same thing. Is that okay? And then this would be the answer. And then, of course, if they want you to get it into complex form, you can get it into complex form. But this is your answer in polar form. Are we okay with that? Any questions? Okay, you try B. I'm giving you a head start. You try B. All right, you ready? You need another minute? You know what? I'm going to mute myself. Y'all talk to each other. Pair share. Start at the beginning. What'd you get for R?
Jefferson, what'd you get, dog? You get 2?
Yeah, I got 2.
Yeah, same. I'm working the multiplication aspect of it right now. What'd you get for the radius, Jude? Or theta, not radius. I got 11 pi over 6. Because negative 1 over square root of 3 turns into negative square root of 3 over 3, which is 11 pi over 6.
Yep, that is what I got as well.
So when you take a tangent inverse of negative 1 over the square root of 3, when you, rationalize it, you get negative 3, or negative square root of 3 over 3. And on the unit circle, negative square root of 3 over 3 is actually 11 pi over 6.
Yep. No, we don't do that.
You don't take the tangent inverse of 2. You take the tangent inverse of what's in your equation that the problem gives you. So you would take tangent inverse of, and tangent is sine over cosine. Okay. Your I is always your sine component. So whatever your I is going to go on top. So
Yep.
you'll have negative 1 over the square root of 3.
I don't know if this is because I don't like the negative exponent, so I just put it 1 over. I don't know.
So I did it. I
'Cause I don't like the
did it
negative
in my
exponent.
calculator.
Yeah.
And it's the same concept.
Yeah.
I put 2 in my calculator, and I got 1 over 1024. And then when you multiply it by your theta, once you simplify it to get it within that 2 pi radius, it's the same way. You're just going to go the opposite direction when you're counting how many times you went around the circle.
Okay. Yeah.
All right, I haven't even started, so y'all are way ahead of me. All right, here we go. So can y'all hear me? Testing.
Yes, ma'am.
Yes, ma'am.
Okay, cool. So you have the square root of 3 minus 1 raised to the negative 10th power. I love the pair sharing, and I loved how much y'all communicated. So I think Jefferson said he got nervous with his negative 10 exponent. Do remember that this is the same thing as 1 over the square root of 3 minus 1 to the 10th power. And the reason why, that's not 1, that's an I. The reason why I want to say that is because if I present it to you like this in your homework, I would change it to this form. Does that make sense?
Okay.
So if your homework says 1 over 2 plus 6i to the negative 18th, to the 18th power, not negative 18th, 18th power. The 18th power, I would change it to 2 plus 6i to the negative 18th power. Because then Garrett made a great point. He said it's the same concept, and it is. Okay. So the first thing that you should do is not even worry about the exponent, only worry about changing this into polar form. So it looks like that y'all got r, which is the absolute value of z, which equals the square root of 3 plus 1, which equals the square root of 4, which is just 2. Everybody got r as 2, okay? And then you started working on theta, and you said that theta is equal to the tangent inverse of -1 over the square root of 3, which is equal to tangent inverse of negative square root of 3 over 3 if you rationalized it. Remember, we're in the fourth quadrant, so that means that theta is equal to 11 pi over 6. So that means in polar form, you have r equals 2 cosine Is everybody okay with that part? We haven't done anything as far as De Moivre's theorem. All we've done is change it from complex to polar, which I'm hoping we've done a lot of practice for. So we're okay. Is there any questions here? Okay. So now what we're going to do is we're going to raise this complex number to the negative 10th power, which means that you're also going to raise the r to the negative 10th power. And then you're going to have cosine of negative 10 times the 11 pi over 6. Plus I sine of negative 10 times the 11 pi over 6. Is everybody okay with that?
Yes,
Is
ma'am.
everybody cool with how we apply De Moivre's theorem? Now remember, 2 to the negative 10th power is the same thing as 1 over 2 to the 10th power. Same thing. And 2 to the 10th power is 1024.
That's what I got.
Cosine of, oh my gosh, I don't know.
Negative 55 pi over 3.
Negative
Okay, well,
110 pi over 6.
Jefferson, what did you say?
I said negative 55 pi over 3.
Oh, maybe. Thank you. Hold on. I'm coming. See, y'all get mad at me when I don't show enough steps, and now y'all are jumping way ahead of me. Hold on. Okay. So then this is, you said, exactly. I'm going to take the negative 110 pi over 6, and you said that is negative, you said 55 pi over 3?
Yes, ma'am.
And then 3 goes into 55 how many times?
18, about 18.3 times.
So 18 times. So 18
You get
times 3.
18 times
54.
with 2 pi over 6, or a negative pi
1,
over 3 left.
a negative pi over 3 left. Is that what you said?
Yes, ma'am.
So a negative pi over 3 left. So technically, that could be your answer. 1 over 1024 cosine of negative pi over 3 plus I sine of negative pi over 3. This could be your answer if they don't make you fix it. Does that make sense? But if they want a positive angle, then you have to fix it. Are we okay with that? It's my dog.
Yes. So
Is there
then
any
you would just
question?
get 5 pi over 3 for your original
Exactly.
answer.
Exactly. I mean, I don't want you to do more work than you have to. If they don't say anything in the instructions about fixing it, then just leave it alone. Leave it to be that answer. But if they start manipulating it, saying, "Oh, we're only accepting angles between, 2 pi and 4 pi or something like that," then you're going to have to fix your angle. Is everybody okay with that?
Yes. Yes, ma'am.
Any questions? Okay. So then the next thing that we're going to do, and I personally, like I'm pretty sure I've learned it somewhere in my past in graduate school, is how to take the square root of a imaginary number. But I cannot for the life of me even know where to start, because now all I do is change it into polar and then do it in polar form. It's so much easier to do this in polar form. So let's see, blank page. Okay. I'm reading the middle of page 115, and it says, if you have a complex number, z equals r cosine theta plus I sine theta, and you want to find your z raised to a root. Now, I want you to look at how they're writing that, how they're writing z raised to a root, because remember, side note, that the square root of z is the same thing as z to the 1/2 power. The cubed root of z is the same thing as z to the 1/3 power, and so forth, right? So even though you don't see a radical, this means root, the nth root of that complex number. If you want to do that, all you would do is you would take your r and raise it to that same fraction, or take the root, the same root. Be very careful. Look what it has here. You're going to have to do cosine of your angle, okay, plus 2 pi k, which is the period for cosine, and you're going to divide it by n, where n is the root that you're taking, plus I sine of theta plus 2 pi k of that root. This right here, you guys, is going to give us the general solution. And what you're going to have to do, I would write that down. Right under the formula, write general solution. Because you can, of course, have more than one answer. You can go around the unit circle a whole bunch of times. And that will give you the particular solution. Okay? So we're going to do one nice and slow, making sure that we understand. But basically, we're just applying the formula. So on example 7, it says we're going to find the fifth roots of 32. The fifth roots of 32. Do y'all see that? Now, do you agree that this would be 32 plus 0i? If I were to write it as an imaginary number.
Yes.
Okay. So then I'm going to change this to polar form. I'm going to do that a little bit briskly since we've had so much practice with it. So to find r would be the absolute value of this complex number, which would give you 32 squared plus 0 squared, which is just equal to 32. So r is 32. To get theta, it would be tangent inverse of 0 over 32, which is tangent inverse of 0, which is going to equal 0. So I get theta equals 0. So that means my complex number is 32 cosine of 0 plus, I'm stopping. While you're writing, please let me know if there are any questions on where I got any of this. Is everybody okay? Any questions? We okay? moving on to the new part.
Yes, ma'am.
Okay. So now what we're going to do is we're going to take the fifth root of this complex number. So if we do that, I'm going to come over here. I'm going to write everything super slow. I'm going to do z to the 1/5, because we're taking the fifth root, equals the fifth root of 32, which is same thing as 132 raised to the 1/5, same thing. Okay. I'm going to do cosine of, big parentheses, 0 plus 2 pi k over 5 plus I sine of 0 plus 2 pi k over 5. It's not always 0. It's just 0 because that was our original angle, which was 0. We okay with that? Me applying the rule. I'm going to simplify this a little bit more. Okay. And this gives me z to the 1/5 equals, what is that, 2?
Yes, ma'am.
Okay. Cosine of 2 pi k over 5 plus I sine of 2 pi k over 5. This is my general solution. Okay? So now what I could do is, if I wanted to, I could say, hey, what is your W, which is a particular solution of 0? So this is telling you, I want you to take your complex number and I want you to put 0 in for k. So it's WK. So I'm going to put 0 in for k. If I put 0 in for k, wouldn't I get 2 cosine of 0 plus I sine of 0? This would be a particular solution. This is if 0 and k are the same thing, if k is 0. Yes. Just a particular solution. So this is your general solution. So if I said, hey, what is W of 2? That means it wants you to take the complex number that you came up for general solution, and we're going to put 2 in for k. So then wouldn't this be 2 cosine 4 pi over 5 plus I sine of 4 pi over 5? Where did what come from? Okay, this is the general solution. Look where it says general solution. So if I ask you for a particular solution, I'm going to use WK. So notice how here k is 0. So I substituted 0 in for k's. Simplified, I got this answer. This one is asking for W2. So that means k is 2. So I put 2 in for k, simplified it, and I got this answer. Oh, it's not. I'm coming up. Remember how I told you over here that it asked for a general, this is a general solution, and that you can come up with particular solutions. So I'm giving you examples of how you can come up with particular solutions.
Can't you, instead of putting a W there, couldn't you just put the K? So like K naught equals all that,
Yeah,
or
absolutely.
K of 2. That way you know what you're substituting.
Yeah, you could do that.
Okay.
I know that some textbooks, they use a W. So I'm just trying to, I don't even know how it is on your homework. You can go look, but I want you to notice, I don't even know what letter they use on your homework. But if you come up with a general solution and they're like, oh, okay, what's J0 and J1 and J2 and J3? I don't want you to come back and say, what's J? I'm going to be like, I don't know. So what's happening is they're giving you a general solution. You're coming up with that. And then they want to come up with particular solutions by telling you what they want you to substitute in for K. Does that make sense?
Yep, that makes perfect sense to me.
Okay. And then notice that. Notice on the instructions, it said, what are the fifth roots of 32? Implying that there is more than one. Does that make sense? Okay.
Yep.
Okay. Moving right along, let's try to do the first page of section 8.4. Section 8.4 is the last section in chapter 8. Okay. And guess what we're doing? We're going to introduce you to another type of graph, the parametric graph. Okay. So these are plane curves and parametric equations. Parametric equations, it's kind of like we're going back in terms of X and Y, but we're going back in terms of X and Y, but we're doing it with respect to time. Does that make sense? We're doing it with respect to time. You don't have to draw this, but if I come over here and here's the X and Y axis, and yes? No, y'all know how to plot points. We plotted them a lot on, the beginning of chapter 8, to plot the complex points. Yeah. So, okay. So the next thing that we're going to do is here's the x-axis, here's the y-axis. Do you agree that the y value is growing a lot faster than the x value is? If I had a graph like this? Do you agree? Here's 1, here's 2, but this is growing a lot faster in terms of y than it is in terms of x. So when you're doing parametric curves, what you're doing it with respect to t. You're still looking at x and y, but I want to know how much time is progressing as you're drawing these. So you're going to have your x function in terms of t. You're going to have your y value in terms of t. Okay. And then your parameter is t. That's what you're basing it off of. Okay. Eliminating the parameter is a curve given by the parametric equations. It's basically going back to x and y. So you're used to seeing things like y equals x squared plus 6x plus 7. There is no t. The parameter was eliminated. So the process of finding this equation is called eliminating the parameter, which means we're trying to get rid of t. So what we're going to do is we're going to start off with very, very simple problems, okay? And I'm going to show you how to do some cool stuff in your calculator. So pull your calculator out, and you want to make sure that you're in parametric mode. So if you have a TI, you're going to the same place where you change it from rectangular to polar, same place. So go to mode, and you should see PAR, P-A-R. I don't know what you see for a Casio because I have a TI. Do y'all see PAR as well?
Yes, ma'am. Mine actually spells it out. Parametric.
Oh,
Same thing.
it says the whole thing? Okay, lucky. Okay. So now what we're going to do is we're going to look at an example. So I'm going to look at the first one, which is x squared equals t squared. And then you have y equals t minus 2. The first thing I want to do, you guys, is I want to actually fill out the table. So if you look at that, using your calculator, go put go put this in your X and Y. So if you go to Y equals now, you should see an X1T and a Y1T. Do y'all see that?
Mhm.
Okay. And when you try to hit your X button, do you see what pops up? Does a T pop up or does an X pop up?
An A or a T?
Mine is a T too. Do y'all see that? So you can actually graph this in your calculator. I would zoom 6 it, make sure you're on a standard window, but I'm going to show you some pretty cool stuff. So if you look at the table, it tells you what it wants you to put in for T. I want you to put in 2 and then 2.5 and then 3, 3.5 and 4. Does everybody see that? So you're going to substitute these numbers in for X and Y to come up with the answer. So for X, you would get 4, 6.25, 9, 12.25, and 16. All I did was substitute the T values into here in order to figure out what X is going to be. I'm going to do the same thing for Y. So I would get 0, 0.5, 1, 1.5, and 2. Is everybody okay with how I came up with my table?
Yes.
Any questions? Okay. Then I'm going to plot the points. When you plot the points, you guys, you're still plotting X and Y. Everybody here should know how to plot points. You're plotting X and Y, but you're taking note of where you're starting, okay, and the direction in what you're drawing. So at 4, 0, 1, 2, 3, 4, 4, 0 is where I'm starting. Make sense? And then I'm going to do this is just a sketch, 6.25 and 0.5, 9, 1. Aren't you going this way? Make sense? And your arrow was drawn in that direction. Are we okay with that? And this is all that you see. Hey, what about the graph over here? We didn't start at time 0. We started at time 2, like 2 seconds in. We didn't start at 0. So you don't see anything over here. Does that make sense? You only see from this point on, because you're doing it with respect to time, not to the respect to its function itself. Now, what would the function itself be? So this is the process I was talking about. We're going to eliminate the parameter to see what kind of function this would be on an XY plane. In order to eliminate the parameter, the first thing you do is I would isolate T in terms of X. Okay, really, all you're really doing is trying to get X and Y together, no T's, because you're eliminating the parameter. Remember, your parameter is T. So we're trying to eliminate that. So then do you agree that here, if I have X equals T squared, that the square root of X would equal T? Do we agree with that?
Yep.
And we have Y equals T minus 2, but T is equal to the square root of X. So I can replace that, the square root of X, with the T, and I would get Y equals the square root of X minus 2. So here's your function without the T. y'all see Desmos?
Yes, ma'am.
Okay. So I want to show you something so cool. I'm sorry? Oh,
These graphs are the same thing?
It's so cool. Let me show you. So in Desmos, how you graph in parametric mode is you open up parentheses, and I'm going to put x in, so t squared. You don't put x equals, you just put what x is. So x is t squared, comma, and then I'm going to put y in, which is t minus 2, close parentheses, okay? But if you look how it did this, look how it started here at 0, at time is 0, and went to 1. So that's all you see because time stopped. But if you look at our table, we want to graph from 2 to 4 for time. So if you graph from 2 to 4 for time, don't you get the picture that you should have in your calculator? Does that make sense? And I'm going to change my graph settings. I don't want it to go from -10 to 10. I want it to go from -10 to like 20 so I can see the whole thing. Okay, so notice how it stopped. It started here at 4:0 where we started, and it ended at 16:2. And then it stopped because time stopped. Does that make sense? You're only growing a portion of the graph based on time. This would be super hard to do in the XY plane because the XY plane is going to try to graph the whole thing, which we'll see here in just a second. But I don't want to graph the whole thing. I only want to graph a certain part of it over a given interval of time. So that's what's happening in parametric. Now, if you come over here, watch this, how cool this is. Just to check to make sure that we eliminated the parameter correctly, I'm going to do y equals the square root of x. Okay, do you see where that is right now? And then when I minus 2, check what happens when I minus 2. Where'd the red line go?
It's gone.
I'm covering it. I'm covering it with the blue line because they're the same thing, except if you notice in rectangular form, it's going to do the entire graph. This bad boy goes on forever. Does it make sense? It has no respect to time. It's going to go on forever. We agree? But if I shut this off again, if I shut off the blue graph, because remember we learned how to do that in lab one time, the red graph will appear. Here's that portion of the red graph when your time is going from 2 to 4. Isn't that cool? So that's what we're doing in section A4. We're working with graphs we've worked with all the time. Square root of x minus 2, you worked with that in college algebra. You know that that looks like a hook and it's moved down 2 units. But what we're doing now in pre-cal is like, I don't want the whole graph. I only want the graph from here to here. You know what I mean? With respect to time, like how are we going to do that? I have a question. Yes, Melissa. So your calculator should have graphed the red part. Did it not? Make sure your window is standard. Oh, so when you go to your window, you have to change your window. If you go to your window, normally it would start at 0. You should see that your t or your time starts at 0. Do you see that? You don't want it to start at 0. You want it to start at 2. And then change your T max to 4. And then graph it. And no, your X min, leave it -10. Your X max, make it like 20. And then when you graph it, you should see what's on my screen. Go back, exit out, tell me what you have in X1 and Y1. T squared? Okay. Okay, and then go to Shift V window, go to window. What do you have for T min? No, but T-min has to be 2. T-min is 2. T-max is 4. Leave the T-step alone for right now. And then your X-min, you can be -10, that's fine. But your X-max needs to be 20 because we're going all the way to 16 on the X-axis. Like you have to fix your window to look like the table that we have in ours. I want everybody to look at the table we created. Notice how your T value, where's my thing? Shoot. I know I'm over. I'm going to stop. The T value is starting at 2. Your T max is 4. Your X min is 4. Your X max is 16. Your Y min is 0. Your Y max is 2. So you want to make sure that your window is fitting all of this, because if you put time as 0, then it's going to start over here. It's going to start at time equals 0. Does it make sense? So you want to be careful and restrict it to what it's telling you to restrict it to. Okay, we'll practice with this more tomorrow. All right, I'll see y'all tomorrow. Thank you.
Thank you.